Have you ever been on a cruise? Well, I am right now, and look, there's dolphins swimming alongside our boat. Dolphins are mammals, which means they give birth and breathe air that live under the water. I don't know if you've ever seen what it looks like deep down in the ocean, but it's really dark down there. Even though you'd think it would be too dark to see anything, dolphins thrive beneath the sea. How is that? I'm Annika, a second year student studying creative technology and design at CU Boulder. Let's take a deep dive into how dolphins are able to thrive underwater, and let's learn about echolocation. Echolocation is the ability to orient by transmitting sound and receiving echoes from objects in the environment. In other words, a creature makes a noise, hears that sound reflecting off of objects in the environment, and then can tell what's happening in their environment around them. While underwater, dolphins navigate almost entirely via echolocation. Echolocation allows them to navigate in the darkness of the ocean, as well as hold their place in the food chain by capturing prey and escaping predators. In echolocation, there are three processes. Let's look at these processes based on how a dolphin accomplishes them. First is sound production, making a sound and sending it out into the environment. Dolphins echolocate by making clicks. They create the sound within their nasal sacs, which is then focused into a narrow beam through the dolphin's melon. These are sounds that are higher pitched than the sounds dolphins use for communication. Some people think that when these sounds hit another object, like a fish or a rock, the object releases its own sound in response. But this isn't true. Rather, when these sounds strike objects, they bounce off the objects, which we call reflecting, and return to the dolphin, and the object doesn't even know. How does this reflecting work? Well, sound travels in waves. The amplitude of a sound wave, or how tall it is, tells us how loud a sound is. The taller the wave, the louder the sound. The wavelength of a sound wave, or the space between the start of one wave and the start of the next, tells us about the pitch of the sound. The smaller the wavelength, the higher pitched a sound is. In water, sound experiences something called attenuation, which means that the farther a sound wave goes, the weaker it gets. Dolphins can use these aspects of sound to adjust their clicks depending on their environment. Whether they need to click louder to account for attenuation, or they're near a rock formation and need to quiet down so the echo isn't too loud, or they're hunting something near the sand and need to lower the pitch of their click to avoid vibrating the sand and alerting their prey. Dolphins know exactly how to adjust their clicks in every situation. These adjustments let them hear exactly what they need to understand their environment, without alerting anything that they're there. Which leads us right to the second process, sound reception. The dolphin then has to hear the reflection of the sound. Rather than hearing the sound in ears, like we do, a bone in their lower jaw, called the pan bone, receives the echo, and then the tissue behind it sends the sound to the ear and the brain. So the sound is made, and then the sound is heard. Then the sound must be processed via our third process, signal processing. This happens in the dolphin's brain, and it's how they turn the reflective sounds they hear into knowledge of where and what objects are. They're able to determine distance based on the time between making the click and hearing the echo, as well as the difference in the sound due to attenuation. They're able to determine direction based on the strength of the echo on either side of their head. And because this is happening to every point in their environment around them, as long as a dolphin constantly repeats this process, releasing clicks every time it receives an echo, dolphins can form a full picture of exactly what's going on in their environment. And dolphins have very powerful hearing thanks to this echolocation. They're able to tell minor differences in density and volume of objects. They can echolocate in loud environments. They can whistle and communicate with other dolphins while echolocating. They can tell things apart at many distances at once, and they can even spot prey hiding beneath sand on the seafloor. So, to recap, dolphins echolocate in order to navigate in their environment, catch prey, and escape predators. Echolocation happens in three processes: sound production, where the dolphin makes a sound reception, where the dolphin hears the sound, and signal processing, where the dolphin then translates the information from the sound into knowledge of its environment. And this system works incredibly well for dolphins. However, there is one big problem with navigating this way, and it's due to something that isn't a part of a dolphin's natural habitat, and that's nets. In order for echolocation to work, the clicks a dolphin releases must have something to hit and reflect off of. However, nets are often made of a material that doesn't reflect sound quite so well. When you combine this with the fact that a lot of nets are a very wide mesh, meaning they're made of strands of material in a grid formation with lots of space between the strands, there's not a lot of material for the sound to reflect off of. This leads to bycatch, which is when a fishery catches creatures they didn't mean to catch, and thus must discard those creatures. And that's not good for the dolphins, as it's easy for them to get caught in nets when they aren't aware of those nets. So, as engineers, it's important to take this into account when designing nets. There's a lot of ways you can make nets more visible to dolphins. We can use smaller mesh nets, or include a more reflective material like metal filaments in the net's fibers to make the net more reflective for dolphins' echolocation. We can also add pingers, which are little devices attached to nets to make noise and scare off dolphins. So, to summarize again, dolphins echolocate in order to understand their surroundings. Echolocation has three processes: sound production, sound reception, and signal processing. And by using echolocation, dolphins have incredibly strong hearing. However, our nets often aren't visible to dolphins, and thus dolphins often get stuck in nets. So we need to design nets with dolphins in mind. Echolocation is a very powerful way to experience the world. As engineers, we have to be aware of how creatures will be affected by the things we design. And now you know the basics about dolphins and echolocation. Check out the full lesson on Teach Engineering, then use what you learned in the associated activities Let Your Ears Do the Walking and Echolocation Experimentation. Can you hear it?